A bunch of people think that Superman is so great. And put Superman up against.
Okay, get out your graphic calculators real quick.
Especially since I was like 95 pounds.
Okay, I don't have the box up here, so if you don't have one, just scooch up next to somebody that does. Get where you can kind of see everything. Okay, and I wanna just show you a trick or two. Okay, so I need everybody facing the front, please. Okay, all right, I want to show you how to use your calculator to do, I'm going to give you one short additional study guide that has exclusively to do with graphing calculator stuff. So on the test, there's going to be, we're going to do an upcoming test, there's going to be a part, an algebra part that covers, the new material, and then there's going to be kind of a graphing calculator part that covers mostly linear regression stuff. But also I want to show you how to do a couple other things. One thing I want to show you how to do is a linear fit. Okay, so let's just say, for example, I'm going to throw a couple of these problems on there, and you can do these multiple ways, but with a graphing calculator, we can even make this easier. Let's say we want to find the equation of a line. Oh, let's say it's going to be through the points 1, 3, and 5, 11. If I want to find the equation of the line through those points, now of course algebraically we know how to do that. I'll calculate a slope from the points. I'll plug in one of the coordinates, the x and y values to solve for b, and we can do this algebraically, but there's a great trick on the calculator. If I go stat, edit, and I put in these two ordered pairs, the x and y values, just like I would for regression, if I've got exactly 2 points instead of a whole bunch, because remember when we did the regression stuff, typically we'd have, I think I gave you lists of like 5 points typically, right? And we found the best fit line, even though the line probably never went through any of the points, right? Remember this stuff? Okay. And it gave us, an average line of all those values. Now, if I've only got 2 points, and I want to find the best fit line, what can you tell me about the line in those 2 points? How many points does it take to define a line? 2. So the best fit line is going to be the what? The best fit line through 2 points, is it an average or is it, can you tell me? Say it again. It's an absolute, meaning what? If these are my 2 points, graphically, and if I have a whole bunch of points, the line's just going to maybe miss all those points. But if I have exactly 2, what's the line going to do relative to those 2 points? Go right through them. Absolutely. Does that make sense? Because there's only 2 points. Maybe I was making that harder than it should have been. Because I've only got 2 points, if I do regression, it's going to be perfect. It's going to give me the line exactly through those 2 points. And instead of being regression, linear regression becomes what we call a linear fit. Instead, it's perfect. Okay? So this is a great trick on a graphing calculator. If I want to find the equation of a line through 2 points, I can just go up, let's erase these lists. So clear, enter, clear, enter, and I'll add those 2 points. So I've got my x values are 1 and 5. My y values are 3 and 11, right? Now what?
Enter graph them?
Well, okay, but how do I gotta do regression. Where do I go to do regression? Yeah, good. Okay, so I'm gonna go stat screen, calc menu, 4, right? Stat calc 4. And now if I just want the equation of the line, you guys get the fancy screen, I don't. If I just want to get the equation, like the coefficients, I can just hit enter, or you guys go down to the bottom and hit calculate, right? If you want to graph it, you'll just go alpha F4, plug in a Y1, and it tells me the exact equation of the line. So the slope is 2 and the y-intercept is 1. Okay? How about that? Does that make sense? Okay? So that's called a linear fit. That's very useful. Okay? Quick way to get the equation of a line through 2 points. Okay, another thing I want to show you. Questions on that? We good with that? Okay? Okay, the other thing I want to show you, well actually one of the 2 things I want to show you is how to graph a piecewise function. Okay, so if I want to do a piecewise function, we go to y equals, and there's a couple ways to do this, but I'm going to show you what I think is the best way. The best way, I believe, is to put it all on one function. You could graph the individual pieces on separate, part of it on y1 and part on y2. Here's the syntax for doing that. It's just a little bit different. What we're going to do is we're going to put the 2 pieces of the function each in their own set of parentheses. So we put, I gotta remember how to do this. I think I'm doing this right. I guess we'll find out if I'm doing this right. So we got parentheses. Let's say we want to do this piecewise function. Let's say we want to do the function f of x equals x squared when x is greater than -1, and it equals 2 minus x when x is less than or equal to -1. Okay, that's my piecewise function. How do I do that? Well, first let's do the top. So we'd have the function x squared, and then I put comma, is this right? Oh, I gotta just put, you know what, I gotta look real quick, so I'm gonna get this wrong if I'm drawing a blank on this. Yeah, okay, that's right. So I close the parentheses. Close parentheses. There's my function. In parentheses next to that, I just put the domain, right? So that's going to be this part right here. So I would put x is greater than -1. How do I do that? Where do I find those symbols? Okay, here's where you find it. It's on the test menu. Okay, and I don't know, well, I do know why. It's kind of weird that they call it test. But a test in math a lot of times would just be, is a number greater than some threshold or less than some threshold? We're kind of doing a test here. We're testing the x value. If the x value is greater than -1, if it passes that test, then this is the function, right? So that's how maybe you can remember that. So we go second, and it's behind math, so second test, and there's our list of inequality signs, and even an inequation sign. Okay? So we wanted greater than, which is number 3, -1. Okay, and I close the parentheses. And if I graph that now, if I just go zoom 6, look what I get. Okay, notice that it only graphs the function on that domain, right? Okay, what do I do if I want to add another piece to this? All I have to do is just go over to the end of this and add, so I'll hit plus, and do the same thing for the bottom function. So in parentheses, we'll put 2 minus x, and then next to that we'll put x is less than or equal to -1. So we go x, where did I go to get the less than or equal? Test. So second test. Less than or equal to is number 6. Less than or equal to -1. Close the parentheses. And I got it. Now if I hit graph, see what it does? Yes, sir.
Mine says,
Find it. Okay. Everybody get that? Get it to work? Okay, now something you got to be careful about here. Notice that if we were to graph this on paper, we would be careful to put what kind of endpoint with x squared? Open, right? Because it's not including the x value. We put a closed endpoint at -1. On our graphing calculators, it doesn't do that, right? The point is so small, you can't tell if it's open or closed. So how could you tell on the graph which one it is? Any ideas how I could know which endpoint is open and which is closed? What do you think, Trent?
The more greater, lesser greater values.
True, but how can you tell? Julie, did you have an idea how you could tell? Okay, you know it based on the function, that's true. I could actually even ask the graph though. If I do this, if I go second calc value and I plug in -1, see what it does? It actually puts the cursor right there. So that means closed endpoint. It tells me the value is 3. I just did second calc value, or the shortcut is, if I have it graphed, if I just go trace and type in -1, because that's my breaking point, right? It'll tell me, it puts it up on the left one. You see that? Yes, sir. Yeah, then you gotta type in -1. You got it? Okay, so then here's the other thing I wanted to show you. There's another issue here where the calculators become very, very handy. And that is, if I want to not evaluate the function at x, if I want to solve a different problem, if I want to say, instead of saying, like you guys have done so far, you said things like f of 7 equals what? And you're able to evaluate the function by plugging 7 into the appropriate part of the function, right?
Yeah.
Okay? What if I ask you a different question? What if I ask you one like this? What if I say instead, let me guess. Okay, what if I want to do this? What if I want to say, find x when f of x equals 8? How do I do that? Now that would amount to setting the left side of the equation equal to 8 and solving the equation, right? Now that looks kind of hard. I mean, we could do it, but there's an easy way on the calculator. Any suggestions? No, you don't. If I hit trace 8, I'll show you. It's good suggestion. But if I hit trace 8, watch what happens. If I go trace 8, see it's plugging in it's plugging in 8 for my x value and telling me my y value. My y value then is 64. That's not what I'm asking for though. I want to know what is the value of x when y equals 8. How could I do that?
You could do it on the. I've gotten on calculator where you can't move the cursor only on the lines. You can move it out into the lines.
Okay, but then I'm at the mercy of where the little trace is putting me, because the trace is like taking little steps along the function. And so if I trace, see the problem is there it's at 8 point, okay, now look, there my function's at 65. If I go down the function here, function's getting smaller, but what are the odds I'm gonna hit it exactly on 8? Not very good. Well, okay, but even there, if I go second table, once again, what are the odds that it's going to be exactly on 8? What if my answer is not a nice, even answer? What if it's irrational or something? See what I'm getting at? Those aren't going to work well because I'm relying on those discrete values. Here's what I can do. How about if I go to the y equals menu and I graph another function? What if I graph a horizontal line at y equals 8? Okay, see what that's going to do for me? So I'll go down to y2. I'll make y2 equal to 8. Now both of them are highlighted, so it'll graph them simultaneously. Now why is that useful to me? Okay, now I can see visually, if I want to know the x values where y is equal to 8, aren't they those two intersections right there? Everybody agree? Okay, so then if I want to know where those intersections are, the calculator will tell me a decimal approximation at least. And so I can go to my calc menu, second calc, and which one do you suppose I want? Intersect, okay? So I'm gonna do second calc 5, and now it's gonna ask me 3 questions. It wants to know, first of all, what are the 2 curves, meaning the 2 functions, that are being intersected? And then it wants a guess, approximately where is the intersection? How many functions have I graphed? 2. So if I had a whole bunch of them on there, I'd have to be specific and say, okay, I want y1 and maybe y4 or something like that. Being as I only have 2, I can just skip through those first 2 questions because there's only 2 to choose from, right? Okay, so you must not have the second one highlighted. You have to make sure the equal sign is highlighted. Yep, just press enter to highlight it. Okay, you might be, okay, this is another comment. I bet I know what's going on. No. Are you in? That's weird. I'm not sure. Let me see if you're in. I can't figure it out right now. Yep, okay, I know what it was. See, you're in transform. You don't ever want to be in that. I don't know why that's there. I'll show you. Okay, so, all right, so back to business here. Sorry about that. So I want to find the intersection. So for the first curve, it wants to know, is it y1? Yeah, it is. So I just hit enter to verify that. Is the second curve y2 equals 8? Yes, so I hit enter. Now here's where I have to be careful. It wants to know a guess. So I've got to trace over to where I'm just relatively close to one of the 2 intersections, and then the calculator will zero in and find it. So if I want to find, say, the left one, I'll just either go over there, or I could even type in an x value if I know what a good x value would be. Like I could say -1, 2, 3, 4, 5, 6, -7-ish, agreed? So if I just put in -7 for my x value and hit enter, it'll zero in on it and tell me that the exact x value is -6. Okay, so one point is that x equals -6, y equals 8. But there are 2 of them. I want to know both x values. And so then I'd have to repeat the process and trace over and find this other one. Make sense? How did I want to do that again? Here, I'll find the other one. So if I want to find this other intersection, remember, here are the steps. I'm going to go second, calc, 5 for intersect. It wants to know, is the first curve y1? Yes. Second curve y2? Yes. So I hit enter twice until I get to the spot where it says yes. And then it puts a question mark there. That's called a prompt. It's prompting me for some information. I can either just trace the little cursor over to where it's close to that intersection and hit enter, or if I can see what a good x value is, like, let's see, 1, 2, 3 looks pretty good, doesn't it? That's going to be close. I could just type in a 3 for my x value and hit enter. And then it'll put me right on that exact intersection, and it tells me that it's 2.8284, blah, blah, blah. Okay? Make sense? Okay, last thing I want to show you, how to do an absolute value function. Okay, this is very simple. If I want to do the same kind of thing, let's say I want to do a problem just like that one. Let's say I want to do find x when for that absolute value function when y equals 4. Okay? Does that make sense? So I gotta put this function in for my y. So I'll go to my y editor, and that first one, I'm gonna go ahead and clear it, 'cause I don't want the piecewise function anymore. How do I do an absolute value function? Well, I just do 2 times. Now I need absolute value. The easiest place to get to it is on the math menu. If I just hit math, go to the number menu, so scoot over to number, it's the first option, ABS. Okay, and then just hit enter. Yeah, the other place I can find it that's also very simple, because it's alphabetically the first function in the whole calculator, if I just go second catalog, it's the first one. That has a catalog of all the functions on the calculator. Because it's the first one, there it is. It's easy to get it that way too. So I'll just grab the absolute value function, and look what it does. It puts in, oh boy, I kind of messed up my menu there, didn't I? It puts in that absolute value, the bars, if you have the new operating system. And if you don't, we'll get that on there.
What happened?
Well, because this emulator I just broke it. It didn't like me scooting around all those menus. So then inside the absolute value bars, I'll just put exactly what appears there. It's just an x plus 2. Then I'll hit the right arrow to scoot out of the bars, and I'll subtract 3. Okay. And now if I just hit zoom 6, there's my absolute value function. I left the y on 8. I really I'd want to go change that, wouldn't I? I'd want to change that to 4 and hit graph. And now I can see both intersections, and so I just go find them with intersect. Make sense? Okay, so now you guys got, those are good tools. That really helps a lot in math. A lot of the math you do in the real world is analytical math, trying to do some analysis of functions. That's very helpful. Okay? All right. So we got a little time. Let's go.
Wait, we have 20 minutes.
Yeah, 20 minutes. That's good. Let's go down to 2:05.